Hello, welcome to another episode. Well, this is the first one. Today I'm going to explain how to write a simple command line interface in Python. And we're actually going to start from a very, very simple example and then build out incrementally. This sample that we started with was originally submitted by PanosTrak on Twitch, kind of as a troll, but then I ended up turning it into a bit of a learning experience. So let's jump into that again. Alright, so here's the sample code that was given by PanosTrak. A bit silly, but he was just there to troll, which is fair. Which is just a simple file that's print hello sexy boy Anthony, which, I mean, that's their opinions. You can let them do that if they want. And you can see if we run it, it prints that out. We're going to turn this into a little bit better of a template that you should hopefully be able to use to build command line interfaces of your own. So let's start with the first problem of this particular code sample. And the first problem is that this code sample doesn't work well if you need to import from this module. So you'll see when we run it, it prints it. But if we import this module, you'll see it also prints it. And usually you don't want import time module, or import time? Module side effects at import time. Usually it's best to have your module and then define functions in it, and only when it's called as a command line do you have your side effects. So the first thing that we're going to do to fix this is take our example code and wrap it in a block that's going to prevent it from running at import time. And the way we do that is if name equals double under main, and then indent this code here. So this little block here will guard against import time side effects. So if we run this again and we do import hello, you'll see it no longer runs that side effect. Now, unfortunately, this hello module is kind of not so useful. Like, we can't actually run this code in the way that it's set up, and we'll fix that in a second. But if we run this code, you'll see that it still continues to work. So the next sort of step of this, or the next evolution of this script, is to give it an actual function. And so what we can do here is take this code and put it into a main function, and then call the main function. This is kind of our next step there. So now you can see it still works if we run it, but if we import it now, we can call the main function. Now you would probably have some more complicated logic here, or like some other stuff to make this particular command line tick, but this is kind of like the dead simple example. The next thing that I would do to this, let's actually make it more than a dead simple example. So we're gonna take some command line arguments as part of the script. We'll probably take the name and we'll make this script a little bit more generic. So let's say we just let's make it some nice gender neutrality here. sys.argv1. We made that an F string, cool. So now if we call this script to python3 hello.py Anthony, you can see that it says hello sexy person Anthony. And if we pick someone else like Jeff or Jordan, I don't know, pick a random name and this script can work for it. Now the thing that I did here is I referenced sys.argv manually, and this has some problems. The first problem of this being if we don't specify an argument, it will error with list index out of range because there wasn't an argument passed, so it exploded. Also, if we pass more than one name, so say we did Jordan and Jeff, it just kind of ignores Jeff here, even though it's probably an error case and we should probably have some errors there. And the usual fix to using sys.argv is to use some sort of argument parser. In Python, there are 3 that are built in. 2 of them are sort of deprecated. Well, one's definitely deprecated. One is sort of deprecated, but still gets used a little bit. But we're going to talk about the one that's not deprecated, which is argparse. And with argparse, you set up an argument parser. I might go into further detail about how argument parsers work, but we're just going to add a simple one for this one. So parser equals argparse.argument parser. And we're going to add one simple argument. That's the person. And we're going to do parser.parseArgs. So what this does is it says there's one positional argument named person, and we'll parse all of those arguments. And so we can use parser dot, no, not parser. We need to assign this. And then we can use args.person. And then if we run that, you can see now it's an error when we pass too many arguments, and we pass just the right number, it prints out the right answer. If we pass not enough, we get this nice little error message that says the following arguments are required person. We also get some other stuff for free from argparse, like it'll give us a help message here, so you could kind of get a basic command line skeleton without needing any of that other stuff. And this is all fine and dandy, but you might want to, again, run this and by importing it. Import hello. If we do hello.main, it's actually going to error on us because we haven't supplied any arguments here. And parser.parseargs actually does the same code that we were doing before, so it's looking at sys.argv. And since we didn't pass any sys.argv to Python, it's going to say, oh, you're missing this argument. But we can work around that. So the way to work around that is you can take command line arguments as an option here. We're going to set it to none by default. This means that when it gets called down here, it's going to pass none in here. And we're going to forward argv along to the parseargs method. Now parseargs is actually super clever here, and I really like this design of argparse. It's one of my favorite parts of it. It's that if argv is none here, it will automatically look at sys.argv. So when it gets called down here, it'll just look at the command line arguments you pass on the command line. Command line arguments on the command line, yeah, great. But if you pass in some arguments manually, so this is a default argument here, if you pass in arguments manually, it will use those there. So we try our same example again. We do import hello, and then we do hello.main, and we pass in, some person name here. So let's do Anthony. Nice and simple. You can see that we can call this function, and we can see its side effect. We can see what it prints. Cool. Great. Let's see. Yeah, probably the next thing that I would do with this program is write some basic tests for it. So let's add a hello test. And I just realized that I have not set up a virtual environment for this yet. So we're going to install pytest, let that go in the background, and we're going to add a little test for this function. Just a very, very simple one. And we'll import hello up here. Let's just test that when we pass in, Anthony, that it prints out hello, sexy person, Anthony. So we would import hello, and we can call hello.main, and again, we can pass in arguments here. And pytest has a lot of nice built-in functionality. We're going to use one of the built-in fixtures here called capsys. And what capsys does, or the longer name is capture system output. I think that's what it stands for. I don't really remember. But capsys lets us see what gets printed and then write assertions based on it. So if we do capsys.readout error, this will retrieve the output that got printed as a side effect of calling this function. So out error equals this. And in this case, we should assert that this gets printed. So assert out equals this. And we should see no error here. Assert error equals empty string. So this is standard output and standard error. And hopefully we have pytest set up now. Yeah, cool. So there's our test. And if we run pytest, what did I call it? Hello test? Yeah. Run pytest hello test. You see we actually have a test failure because I forgot the new line. Tricky new line. Yeah, so print automatically adds a new line to this, which makes sense. It's like prints doesn't all get bunched up on one line. So fix that test, and hey, we have a passing test. Cool. But we might want to test the return code of this function. And actually, we want to make sure that our program exits with a proper return code. So let's change our command line a little bit so that it's an error if we pass in, I don't know, some error case. I guess like the empty string, if you try to ask, or if you try to, yeah, let's make empty string an error. So if args.person equals the empty string, Maybe we print some error. Print person's name, double quote, must not be empty. And then let's say we do return 1. In reality, you would probably use the error method of your argument parser because that'll actually give you, a better error message, but for the sake of example, let's do this because it fits better into the problem. And in this case, we want to return 1. So this, hopefully, if we do everything right, should end up as the return value of the program on the command line. You'll actually see that this is not quite set up properly, and we haven't gotten to our full skeleton yet, so it won't successfully do that. But let's write a test that kind of validates that. Test main error with empty string. We'll use capsys again, and we want to do assert hello.main with the empty string. Does not... Yeah, well, we can just use assert here. So we're asserting that the return value here is non-zero or non-none. Basically checking that it's an error case. In command lines, 0 is successful and everything else is unsuccessful. Because it makes bash scripting convenient or whatever. And we'll again grab out an error. And we should expect to see that the output is, this string here. But there's no output, it's only error this time. Oh, we forgot to send this to sys.standard_error. Easy fix though. Assert error equals this. And new line at the end, because we forgot that last time. And if we run this test now, cool, we have 2 passing tests. But unfortunately, this isn't actually true. We've kind of lost a little bit here. If we run this script, python hello.py, and pass in the empty string, you can see we get this error message, but it's still returning 0. And the reason for that is we're just calling this main function. We're not actually getting the return value here. There's kind of 2 solutions to this, and I'll tell you why I like one over the other. The first is to use, sys.exit here. And so that would work. That would change this empty string case to be returning 1 as the error code. And that works, but I don't really like that case. And you'll see why when we run our tests. Yeah, so this now raises an exception because sys.exit is implemented as the system exit exception. And so our test now fails even though it's kind of working properly. Now we could adjust our test to check for that. Do with pytest, import pytest with pytest.raises system exit as exception info, and then call the main function, and then args, or I guess retv equals exception info.value.args. And then assert retv equals 1. But you'll notice this is a lot more verbose than what we had before. But I believe this works now. Pytest, pytest, hello test. I've got my muscle memory from before. Yeah, so that makes the test pass. Usually I put my tests in a test directory, so that's why I tried to type out pytest tests there. But yeah, so this works, but it's a little bit clunky. I don't really like it, so we're gonna go back to what we had before, which is this here. And I'm gonna show you how I would adjust this so that we both get the return value on the command line, but we can also easily just test it from the return value of this function. So we'll put this back to return 1. And the easiest way to do this, now there's some problems to doing it this way, but the easiest way to do this is to just change this to exit main. This is actually what I prefer, but I'll show you some places where this doesn't quite work out how we would want. So if we do this now, the return value here will end up on the command line. So let's show that. Python hello.py with the empty string. Oh, we should use Python 3, but whatever. Cool, so we get our return value there. And if we run our tests, those also still work. So great, everything works great there. But there's one problem with this particular function here, just named exit. So this actually gets set up by a special module in Python called site. And the the things that are set up by site are not always present in Python. I forget what the argument is. I want to say, let's see, site. Don't add user site. Don't imply import site. Yeah, so this -s will actually make exit not available. So if we look at Python 3 and we look at exit, it's this special object that prints this out when you look at it. You can actually see special site built-ins.quitter thing. But if we run Python 3 -S, you'll see that exit is not defined. So there are cases where this is not a built-in function. It's just like magically global if site is set up. Now, 99.9% of the time you can depend on site being set up because, you know, Python's pretty useless without site. Like you can't, you know, import most of Python stuff that you would install. So like, I have pytest installed, but we can't import pytest, and like basically anything you would install is not available. Because that's what's part of site packages, and that's why that's called site packages. But I don't know, most of the stuff that I build, I just assume site is available, and so I write this. And I know I'm wrong, but sometimes it's okay to be wrong. Probably not in this case. So there's two alternatives if you want to be a little bit more, you know, pedantic or correct here. You can use sys.exit, which we've imported sys. The one downside to sys.exit is you have to import sys, which I don't know. It doesn't actually matter because sys is always imported, kind of, or at least it's always part of the Python startup. And so importing it isn't slow or whatever. So this is a more correct solution, but I don't like importing. I don't like importing if I don't need to. But there is another way to do this without importing. You can use raise system exit. But then if you're not familiar with exceptions, this might be, you know, some daunting syntax here, and you might be like, what is this doing at the end of my file? But that'll work as well. So we do Python 3 hello.py, empty string, sys is not defined. Oh right, because I deleted the import. We're actually using sys here to print a standard error. And we'll get that return value here. Oh, one other question that I got when I was answering this on stream is, what is this $? Thing? And this is a special variable in bash, which refers to the exit code of the previous command that got run. So if you see like bash-c exit2 and then echo $? You can see that like this exit code of this command here is represented as this variable. And you can actually use this and assign it to some other variables. So let's say we did bash-c exit 42, and then you can assign prev exit code to that variable, and then if you wanted to use that in somewhere else in your script, you can, and that'll persist as a variable for you. Yeah, back to this a little bit. The last thing that I would change about this is one thing that I've been doing in all of my projects, which is to add type annotations to everything. And we'll switch it back to exit main because that's the way I like it. Now, type annotations are optional in Python. They don't really change the runtime of the program, but you can validate them statically with a number of type checking tools. So let's annotate this. So first we would start with argv, which is going to be an optional sequence of str. And this is going to return an integer. Now we need to import those from typing import optional and sequence. Now, the reason that I pick sequence here over list is parse args can actually take tuples or lists, and sequence of str is kind of a nice middle ground there. And optional here, I'm being very, very explicit that if you pass none, that's okay, but otherwise it should take a sequence of strings. And if we do that, we'll actually see that this doesn't quite validate with mypy. Git install mypy. MyPy is one of the many type checkers that you can use. If you do mypy hello.py, you'll see that it's complaining about a missing return statement. And that's because we only return an integer on this path here. The rest of this function doesn't actually return one. So we want to go return 0. Then success! It type checks properly. And pytest hello.py. Hello test, right. And the test pass. Cool. So that kind of concludes this little demo of how I usually set up command line interfaces. Just to recap a little bit, we default argv to none so that parseargs can use the command line normally. So if we do python3 hello.py Anthony, this is how parseargs gets access to this variable here. But we allow it to take an optional sequence such that we can write tests to test it. Look at hello test.py, we're passing in a list of strings here, and this is what gets fed in as the program arguments to the argument parser here. And yeah, and then this block ensures that it only runs the main function automatically as part of running it as a script. You can also run it as a module with python-m hello.py. Oops, not hello.py, python-m hello. You're right, -m takes a module path, and so this would have looked for the folder hello and then the py module inside of that. So quick little typo there. But if we use python-m hello, then it'll run it as if I ran it as a script. And double under name is also equal to double under main in that case. Oh yeah, this is kind of a little bit tricky. So there's some globals of modules that are populated automatically. One of them is double under name. And the reason this block doesn't run when you import it, import hello, is double under name of hello is actually the name of the module. And so normally when you import stuff, it has the name of the actual module name itself. It's a little bit meta and a little bit magical, but that's how that gets set up. But when we run it as a script, it gets the name double under main. So actually, if we look at the double under name of this interactive session, it will be called double under main. And so that's how this if statement works. But yeah, this little bit of code that was originally kind of sent as a, haha, code review this. And I expanded it out into a little bit of a learning experience. So hopefully you guys learned some stuff. But this is what we ended up with. Test.py. And yeah, hopefully you learned something. If not, that's fine too. But yeah, if you guys have other stuff that you want to see, feel free to leave comments about like stuff you would want me to explain, or stop by my Twitch stream and you can ask questions there. But other than that, thank you all for watching, and I hope to see you guys around in the next one. Cheers!